Today we're going to continue our discussion of similarity, talking about similar triangles. You're given this diagram and the statement, the triangle BTW is similar to triangle ETC. And what we'd like to do is write a statement of proportionality. Now, I'm going to just write out a lot of the things I see happening here. I know that ET and BT correspond to each other because they're in the same corresponding positions. So I know that I can compare ET to BT, and that should give me the same scale factor as comparing anything else that's in the same corresponding position. So for instance, I know that TW and TC can be compared. And let's see, I'm actually comparing the small one to the bigger one because I put the smaller one first. So that means that's going to give me the same scale factor as TC to TW. I also know that CE and WB can be compared because they're in the same corresponding positions. So that should give me the same scale factor as CE to WB. Now, given all of this information, let's find the measure of angle TEC. Well, it looks like TEC, this angle here, and angle B are in the same corresponding positions. So if these triangles are similar, those corresponding angles should be equal. So TEC should also be 79 degrees. We can fill that right in. Now we'd also like to find the length of ET and the length of BE. So let's start out. Let's see if we can find ET first. Well, let's see if we have any proportions set up with ET. Yes, we do. We have the ratio of ET to BT is going to give us a scale factor. So let's set that up. So we know that ET over BT, and guess what? We know side BT, which is good. Let's see what other sides we know. We do know side CE, and we know WB, and look at that. We have that as part of our statement of proportionality. So ET over BT is equal to CE over WB. And now we're just going to fill in the numbers. That's all that's left to do. So we're going to, we don't know what ET is, so we'll call that X. BT is 20. CE is 4. And WB is 12. So now let's cross multiply. And we end up with 12x equals 80. Divide each side by 12. So I end up with 80 divided by 12. And let's round it to the nearest tenth. That gives me 6.67. Or not nearest tenth, let's round it to the nearest hundredth, I'm sorry. So 6.67. All right, so ET we'll say is 6.67. That's ET. Now, it said find the length of BE. Well, look at this. We know the length of BT, which is 20. We know from E to T it's 6.67, so we can just subtract that 20 minus 6.67, which is really 6 2/3. 20 minus 6.67 gives us 13.33. And that gives us the length of BE. Okay. Now don't let this confuse you. Don't let it frustrate you. This will come with practice. With similar triangles and similar figures, it just takes a lot of practice, and that's what we're going to be getting in class. So don't be discouraged if you don't get everything on the first try. okay, because we will be doing a lot of practice with this, and I will be there to help you. Next, we're going to talk about something called angle-angle when it comes to similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar, and that's all you need to prove that those triangles are similar. And we're going to be demonstrating these in just a few moments. Next page, side, side, side. When we're dealing with similarity, if three sides of one triangle are proportional to three sides of another triangle, then the triangles are similar. So we're talking about if the scale factor is the same. So three sides of one triangle proportional to three sides of another gives you similar triangles. Next, side angle side. If two sides of one triangle are proportional to two sides of another triangle, and the included angles are congruent, then the triangles are similar. We call that side angle side. These are probably ringing a bell with you because you're probably thinking of the congruence, the ideas of congruence with side angle side and side side side. It's kind of similar, except now we're talking about sides being proportional rather than congruent. And we'll see how these work in just a moment. We will be moving on to some examples right now. So the question that you're going to be asked is, are the triangles similar? Are they similar? Yes or no? Well, let's take a look here. We are given this triangle. Now we're talking about the outer triangle and the inner triangle being similar. We're told that these two lines here are parallel. These two segments are parallel. If they are parallel and they're cut by a transversal, which we see happens here with these sides, that makes the corresponding angles equal to each other. We also know that the larger triangle and the smaller one share this same angle, so that angle is equal to itself in each triangle. We now have enough information to say the triangles are similar. We're going to say yes by angle, angle. Now next, we're given these two triangles. We know two angles in each triangle, and we know that the 72-degree angles are equal to each other. We don't know the third angles, but we can find out what the third angles are in each because the three angles of a triangle add up to 180. So we have 39 plus 72. If we add those together, we get 111. 180 subtract 111 gives us 69 degrees. So right off, we're looking at this and saying, wait a minute, okay, so can these be similar? Well, let's take a look and see if we can find out the third side over here. It doesn't look like that's going to happen, but let's see. So over here we have this triangle with 79 and 72 degrees, so let's find the third angle. 79 and 72. If we add them, gives us 151 degrees. 180 minus 151 gives us 29 degrees. So our missing angle is 29 degrees. So we've got one pair of angles congruent, but not both pairs. So that's not enough to prove that these triangles are similar. We would need two angles to use angle, angle. So we're going to say no, those triangles are not similar. Now let's look at these two triangles. We have that these segments on the ends are parallel to each other. Well, when you have when you have parallel lines that are cut by a transversal, which we do right here, we can say the alternate interior angles are congruent. So we know these two angles are congruent. Now the other thing we know is we have vertical angles here. So these vertical angles are congruent. And we have enough. All you need are two angles of one triangle to be equal to two angles in another triangle to show by angle that the triangles are similar. So we're going to say yes, they are similar by angle. Now moving on to these two triangles. Notice we have these two right angles in each triangle. So those angles are congruent. We're set on those. Now we are given two sides in each triangle. Let's see if the corresponding sides are proportional. So the side with the 9 corresponds to the side with the 6, and 9 over 6. If we divide each by 3 to reduce, we end up with 3 over 2. Well, the other sides. 12 corresponds to 8. So if we divide each by 4, we end up with 3 over 2. So it looks like those are proportional. So we have side, angle, side, side, angle, side, which allows us to prove the triangles are similar. So they are similar by this concept of side, angle, side. Next, we are given this picture. Here is a man standing, or a person, I should say, standing, and then here is a tree. And notice we have these similar triangles that are being made by this angle of elevation. The person is 5 feet tall. The tree is x feet tall. To this point, from the person's feet to this point, it's 6.5 feet. From the base of the tree to the point, it's 8.5 feet. We'd like to find the height of the tree. So let's go ahead and see if we can figure this out. These triangles that are being created are similar. You should assume that right off. And what we're going to do is see what corresponds to one another. The height of the tree should correspond to the height of the person. They should correspond. So we have x compared to 5. So the base of the tree should correspond, from the point where the angle of elevation begins to the base of the tree is 85 feet, and that should correspond to where the person is standing to the start of that angle of elevation. So that's 6.5 feet. So we're going to say 85 feet should correspond to the 6.5 feet. And now what we're going to do is solve by cross multiplying. So you have 6.5x is equal to 5 times 85, which gives you 425. We want to divide each side by 6.5, and I get just a moment. So I have 425 divided by 6.5. I get that x is equal to, and if we round it to the nearest, let's round it to the nearest tenth, is equal to 65.4 feet. So that is the height of your tree. Thank you for joining me.